relations versus functions, okay? So, and this is review stuff from Algebra 1, relations and functions. But we're going to go ahead and talk about it because I don't want to assume anybody knows it and then find out later that you don't know what I'm talking about. Okay? So, here's the deal, Pickles. Everything's a relation. Everything is a relation. Everything. Anytime you're talking about two different variables, you got two different things involved, that's a relation. Now, that doesn't mean that one actually causes the other. That's not what that means. Relation just means that you have this and you have this, and they go together in some way. All right? For it to be a function, some very specific things have to happen. Well, basically one very specific thing. For it to be a function, all of the x values or the independent values must be unique. Okay? That's what makes it a function. So, taking this content right here, this very idea of it all has to be unique, and applying it to this information right here. Now, first of all, do y'all remember what this is called? When you've got this adorable little graph-looking thing right here? Well, these are your x's, that's right, and these are your y's. But what is it called when we put it in this picture? Does anybody know? Am I going to have to move you two? Juniors and 10th graders? You're not? Are you a junior? I thought you were a 10th grader all this time. Okay, this is called a mapping diagram. A mapping diagram is when you have these little boxes and these arrows like this, okay? So this means that you have this point, 150, where 100 is your x value and 50 is your y value. And then you have this point, 200, 100, where 100 is, where 200 is your x value, 100 is your y value. And then you have this point, 300, 150, where 300 is your x value and 150 is your y value. So for every x we have a different y, right? We have an x, y, x, y. For every x, there's a different y. Do y'all see how that works? So this one is a function. And it's more specifically known as a one-to-one function because every x has its own y value. Y'all follow what I'm saying? So one-to-one just means every one x has its own one y. And nothing repeats. Nothing's the same. Okay? So here we have another mapping diagram right here. We got our domain here. We got our range here. And for this one, if this is our x, these are our y's, right? So our x is 3, our y is 1. But then also our x is 3 and our y is 5. Now, is that a function? No. This is not a function. Why is this not a function? For it to be a function, all your x's have to be different. And see how we have the same x in both of those guys right there? Since the x's are the same, this is not a function. Not a function. Bless you. Bless you. Okay, so look at this one. This is called, do you want to remember what this is called when you have it written like this in this cute, adorable little format here? It's so sweet. It's on a graph. It's a table. It's actually called a table of values because it's numbers. Table of values. That's what it's called. Now, we could just say table. That's cool. But if I say table of values, I need you to know what I'm talking about, right? Table of values just means a table full of numbers. Okay? So for every x, this is our y. So we have 1, 2. Y'all, that's just a point right there, right? We have 2, 4, another point. And then we have 3, 6. So is this a function? Yes. Yes, this is a function. Is it a one-to-one function? Yes, because every x has its own y, right? Nothing repeats. Okay, so yes, it is a function. Yes, it is also a one-to-one. I just realized we haven't been talking about domain and range. I'm going to have to go back and pick that up in a second. But I'm going to go ahead and finish is it a function or not? Game show, okay? Now, what is this called? This sweet baby right here. This is a graph. So we have looked at 1, 2, 3 different interpretations of data. We've looked at mapping diagram, a table of values, and a graph. That's not the only options there are. You could also have a number set. And a number set is when you literally have a set of numbers. The number set. See how the name goes with it? Y'all know I was teaching before I realized that the words number set literally meant set of numbers. Like, that didn't make sense to me. Now it does. You could also have a list of coordinates, like this right here. See that list of coordinates? It's another way of looking at the same data. Okay, so we look at this one. This one's kind of tricky. I don't want anybody to shout out an answer yet. I want you to really think about it. I'm going to give you like a full 30 seconds to think it over. Okay? Is this one a function or not? Decide what camp your answer is going to be on. Do you have an answer in your head? Everybody have an answer in your head? All right, we're going to do a thing. Stand up. Stand up. Y'all need to move around a minute. If you think number 4, that graph, that's a circle, is a function, go stand on the door side of the room. Do you think it is a function? You say no?
If you go, I go.
You trusting them two there? You just trust him? You don't trust Emmanuel? Randy, are you with them? Oh, you're not with them? Okay, if you think it is not a function, go stand on this side of the room. Come on, Jacob, get up and move around a minute. How often do you get a chance to get up and move around during class?
Come on, Webber, come here.
He's working. He's missed too many days. He can't afford to not be working. Okay. Can one of you tell me why you think it's a function? Like, what's your reason? Huh? All the x values are different? Do y'all agree with him?
Yes. I got the one.
Wait, hold on.
I got the reason one.
They are different.
Look, okay. It's like every x, there's a y. Like if you connect it around the circle. I think like every point of the circle.
Hey, well, it's not that serious.
Okay. It could be. You quit. You quit.
Could be a major.
Yeah. Okay. Now, I will tell you right now that I admire your bravery over there. Because you are the only ones who thought what you thought, and you still stood up for what you thought was right. You're wrong. You're wrong. But I think it's way more important that the three of you are over there by yourselves and that all of you are together. Because even though you were wrong, you were still brave in being wrong. Y'all, everybody go ahead and have a seat. Let's talk about it. Let's talk about it. Okay, so here's what's going on. Remember, all the x's have to be unique. And that is what Emmanuel said. All the x's have to be unique. Here's the problem. They're not. They're not all unique. If I draw any sort of vertical line on this piece of paper, I don't have a ruler. I put my rulers all up today. Any sort of vertical line here. Let's say I draw a vertical line right there. Right? Y'all see that pretty vertical line right there? Now, this point, this point right here is like roughly 0, 2. I don't know it's not exactly right, but y'all get the idea. And then this point right here is like roughly 6, 2. Did I write that backwards? I sure as heck did. 2, 0 and 2, 6. And what is the same on those? Which are what values? X's. And the X's, to be a function, the X's have to be unique. Now, easy way to test it. If you can draw a vertical line, and that vertical line crosses more than one time on that graph, not a function. Okay? Because that means that both of those locations, X has to be the same thing. Anywhere you draw, I know that's not very vertical. Anywhere you draw a vertical line and it crosses more than one time, not a function. Okay? Everybody good so far? All right, look at number 5. Function or not a function? Without graphing it, just function or not a function? Not a function. How do we know? Look at those X's that are all 2. Right? Those X's are all 2, so that's not a function. Look at number 6. Function or not a function? Function. Look at number 7. Function or not a function? It is a function. Look at your X's. X is -3. X is -2. X is -1. X is 3. It is a function. All your X's are different. What about 8?
Not a function.
Not a function. Okay. This one was a little bit of a trick. So it says X equals -2. That means that no matter what Y is, guess what X is? -2. No matter what Y is 5, X is -2. Y is 7, X is -2. Y is 0, X is -2. Y is 1, X is -2. Y'all see what I'm saying? No matter what Y is, what is X still going to be?
2.
-2. This winds up being a vertical line. Because no matter what Y is, Y is 0, X -2. Y is 1, X -2. Y is 5, X negative. Y'all see what it looks like? Okay. And what do we know about vertical lines? They're not a function. They're not a function. They are straight. That's true. I ain't lying about that. Okay. Now, let's say, what's the time? So give me a time check.
201.
Oh, we're doing so good. Okay, so let's say that I ask you for the domain and the range of each one of these sweet babies that we went over already. Now, what does the word domain mean?
X.
That is all possible X values. Now, based on what you have, that could be a list of independent numbers. Or it could be a, like, X is greater than or X is equal to or X is less than situation. Right? So, like, right here, because they gave us specific values for X, our domain would be this list of numbers. 100, 200, 300. And our range would be this list of numbers. 50, 100, 150. Right? Right here, what would our domain be? 3. Just flat out 3. What would our range be? 1 and 5. Y'all see how I'm writing these as sets of numbers with the little squiggle thing? That squiggle thing is hard as heck to make. Do the best you can. It don't have to be pretty. I'll let you get by with it. But you got to be real careful that it don't look like a point, right? You don't want it to look like a point. Okay? What about our domain on this one right here? 1, 2, 3. That's it. What about your range on this one? 2, 4, 6. Okay? What about your domain on this one? So this one is a little harder because you're not going to be listing specific numbers. This one you're actually going to give a range of values. What is the smallest x that this could be? What is the smallest number you have going side to side? 0. So 0 is your lower limit, right? And then your upper limit is how far do you get this way? I think it's actually more than 10, but we're going to write down 10, okay? So x has to be what compared to 0? Greater than or equal to what to 10? Less than or equal to. And that's how you would write that domain. X is greater than or equal to 0. X is less than or equal to 10. See why it was important for us to understand how to read that the other day? You remember that now? Okay, what would our range be on this? What is our smallest y value? What is the lowest we can go? How low can you go?
0.
-2 right there, right? So that's going to be our bottom limit. This is our y values, not our x's. So what does it have to be to -2? Greater than or equal to. What about our highest? How high can we go? So technically I think it probably is above -8, but let's go with -8 just for the fun of it, okay? Just to make life a little... I mean, technically it is looking like it's a little higher, but we can't really tell. I don't know why I put a -8. I think possibly because I'm crazy. Okay? +8, right? Y is what to +8? Less than or equal to. So that's our domain and range for those guys, right? Right here. What would our domain for this be?
2.
Our domain here is just 2. What would our range for this be?
-1.
Oh, this brings up such a great point. Did y'all hear how Alex said -3, -1, 4? I think Carlos also said the same thing, but I heard Alex stronger. Okay. Is that the same order that they're in up here? No. So we put them in order numerically. And we don't duplicate anything. So we don't have to say 2, 2, 2, right? We just say it one time. Okay. What about our domain for this one?
6.
So our domain is 2 and 6. And what's our range? It's also 2, 6, right? Notice that this x and this y don't match each other. Those are not mates. They're not buddies. They're not partners, right? When you're listing the domain and range, you're not listing them in order that they appear with everything else. You're just listing the possible x's and the possible y's. What's up? Do you have a question? Okay. Yes. Okay. What about this one? What is our domain for this guy?
-3,
-3, -2, -1, and 3. What's our range?
1. No, it's -1, 4, 4.
-1, -1, 4, 4.
-1, 4.
-1 and 4.
Okay, remember, when you're listing domain and range, you don't have to say every time it happens. You're just telling what the possible ones are, right? So we're not going to list -1 multiple times. We're just going to put -1 down one time. We're not going to list 4 multiple times. We're just going to put 4 down one time. Okay? What about number 8? Our x values are -2. What are our y values? What's our lowest y? It's infinite, right? What's technically what kind of infinite? Negative infinity. And what's our highest y? Positive infinity. So technically, our y's, we could write it a bunch of different ways, but we're going to write all real numbers, which can be abbreviated like this. This funky R with two like legs. All real numbers. If you ever see this, you know they're saying all real numbers. Okay? Now, real quickly, this is a line, right? This is a line. That means even the points that aren't points are points. So even like this little location right there, that's a point, right? It's not a whole number point, but still it's a point. It's on that line. This data is what is known as continuous data. It doesn't stop, right? It's not specific locations. It's everywhere on the line. This data also in a line, right? It's also in a line vertically. It's in a line. This is called discrete data. And it's called discrete data because each individual point is the data, but not between the points. Where on this one, it's everything. Where in this, it's just the individual points. That's called discrete data. This is called continuous down here. This is called discrete. Y'all with me so far? Question so far? Discrete data, individual points, continuous data, it's a line. Okay? It's a line if you have an equation. It's discrete points if you have specific points that you're not connecting. All right, last piece of information. Do y'all know how to read this right here? Y'all know how to read that? How do you read that? So you can say f of x, you can say function of x, right? Either one of those are acceptable. It technically stands for function of x, but do you know you don't have to use an f? Like you can use any variable and it still has the same meaning. We just normally use f because f and functions start with f. So that's why we normally use f. But if you've already got one using an f, you can use a different variable. Guess what we normally use after we use f? Anybody know?
Y.
G. We normally use G. And then does anybody know what the next one is we normally use?
H.
We use H. So we start with F, then we'll use G, then we'll use H. And then from there, it's just a wild party. Like, does that mean you have to use F first, then G first, then H first? No. It don't. It just means that those are traditionally what are used in what order they're traditionally used in, but there's no rule about it. There's no rule. All that is a variable. That's all it is. It's just a variable, right? So if we have this says function of x equals 2x minus 1. That function of x, we generally think of that as just being a placeholder for y, right? It's a placeholder for a different variable. And if it says function of x equals 2x minus 1, and then you get this business where it says function of 0, then what they're saying right there is, oh, hey, I want you to take 0 and go put it in that function where x is, and then do the math and tell me what you get. So if we're looking at function of x equals 2x minus 1, but we're putting 0 in the place of the x, that means mathematically we have 2 times 0 minus 1. And then we just do that math. So what is 2 times 0 minus 1? And so that would be your answer, negative 1. If we had the function of negative 2, knowing that the function of x equals 2x minus 1, we would do 2 times negative 2 minus 1. So 2 times negative 2 is, negative 4 minus 1 is And our answer is negative 5. If we had the function of 12 and we stick that in, so we've got 2 times 12 minus 1. What is that?
23.
If we did this one. Now, notice this is different. This is G. G is a different equation. So we're going to do 2 minus negative 1 squared. Now that negative 1 is being squared. What happens when you square negative 1? Positive 1. So that's going to give us 2 minus 1, right? What is 2 minus 1? And then like number 4 there. So that's going to be 2 minus 4 squared. Notice that's not a negative 4, that's minus in whatever you get when you do 4 squared. What is 4 squared? What's 2 minus 16? Thank you. Okay, and then, F of D. That means we're going to replace X with D. So where X is, now we're going to put D. So we're going to have 2 times D minus 1. Now, can we actually do anything with that? No. So that's it right there. That's our answer. That's all we got to do. That's it. Okay? So that is this whole lesson. I told you this is pretty basic. We're just refreshing your memory on some stuff. Right? So, what is time check? We have 6 minutes. So, for the next 6 minutes, I want you to try 1 through 11 odds. Let's see how many of those you can get done. 1 through 11 odds on the back.